All right, everybody, discover your seats. We will get started with the next session here. Want to introduce today's speaker, who will be talking about ESnet's OSCARS modernization for LHC data challenges and IRI. Evangelos Chaniotakis I got it wrong, is a longtime engineer with ESnet. He told me 17 years, which is just a little bit less than I've been there because I'm with ESnet as well. But we'd like to invite Evangelos up to the stage to give his presentation.
Well, thank you, Jason, and thank you, everybody, for joining me today. It's been a while since I've been on a scenic event, and this has been like a big change from last time that I was here. I'm very happy to be here and representing ESnet and talking about what we've been doing with OSCARS. And first, a few words about ESnet. Probably most of you here are at least a little familiar with what we do. We are the Energy Science Network. We are the Department of Energy's data network. We connect all our large labs. We connect, I don't know, I think our latest backbone is about 800 gigs. And with about 800 gigs of transatlantic capacity, we connect. So I don't even know how many national labs and instruments, and we cross-connect to a lot of internet exchanges and R&E exchanges and institutions. Many of them, like from this audience, our aim is to provide like the connectivity for the cloud, the internet, the research collaborations, basically enabling data science for energy sciences and the global community. We are about 120 people in ESnet. About 30 of us are in the software group. Just to give you some numbers, my particular group is about 15 people for the automation side of things, which OSCARS is a part of. And I've been part of the OSCARS project for quite a while now, since Jason mentioned. The team has grown and shrunk. Now we're like basically 4 or 5 people. And I'm just going to go ahead and explain what OSCARS is. It's, if you have not heard of this before, it's ESNet's Layer 2 VPN provisioning tool. And it's one of the oldest one that I'm aware of. We've been doing like network as a service before really the term happened. And before I joined ESnet, I joined in 2007, and it's already has been in production, I think around 2005 or so. Our main like claim to fame is that we can do, guaranteed bandwidth, we can do traffic steering and engineering, and we can do advanced reservation of resources. So you ask for something, not right this minute, you can ask for it with, a time in the future for a specific period of time. And setting up a layer 2 VPN with certain parameters like what bandwidth do you want, where do you want to go, where do you want it to land, and stuff like that. The project has gotten awards from R&D magazine, DOE secretary. Actually, even Cynic gave it an award a while back. So it's been like quite a successful project, and we have, as far as I remember, 120 layer 2 VPNs live on the network right now, with more coming in and out basically on a daily basis. And that is something that is probably going to change towards becoming a lot more frequent. One of the things that we want to, focus on, we've been interoperating with the Sense project. I'm going to talk about that a little bit later, but it's basically like the network resource provisioner for the Sense RUCIO like stack. This is a screenshot of today's OSCARS, web user interface. And I didn't actually do a demo. It would be kind of like a difficult thing to set up because it's all behind VPNs and whatnot, but it's an engineering focused tool. You get like a graphical representation of the network map. You can see a segment of it right there at the top. You can see our, ESNet's Bay Area network. You can see like, oh man, I'm sorry. So this is like over there, and you can see our different like core routers, and you can basically like ask the system to give you, a VPN. In this case, you can build a 3-point VPN that is, fully connected between all the points of this, you can kind of see over here on the left, there is one router with one port and one VLAN, then another and another. And here on the bottom, you can kind of see them interconnected with LSPs for basically a VPLS instantiated layer 2 VPN. And you have options for some scheduling, you have some, other technical MTU, some metadata, and all that stuff that is, what the engineer can see when they set up a layer 2 VPN. Now, so I'm going to talk a little bit about how we were in basically like September of October 2023, which is where a lot of the story actually like starts to become a little more urgent. Like I said, this has been in production for about 17 years. It's been carrying a lot of, baggage and technical debt and existing like compromises to its model, and still kind of does. But in 2023, a few things aligned for ESnet to want to move forward with developing and pushing some more effort in improvements to OSCARS and modernizing it. So one of the things that came up is the LHC data challenge. So what, if you guys don't know what LHC is, it's the Large Hadron Collider. It's in Geneva. It's a big instrument, and it generates a metric truckload of data. And ESnet is tasked with transporting most of it to the supercomputing facilities and data storage to the US, and then all this stuff gets pushed onto other institutions inside the US. And every year before they turn up the instrument, they do a data challenge, which means like test out the network and all the infrastructure to make sure that it actually works to the specification that they need. And this year they are planning to increase all this required data because they improved the collider to do more stuff, have a bigger resolution in its detectors, generate more data. Therefore, you need to push more data out of Europe and into the US. And therefore, ESnet, our organization, decided we need to upgrade our backbone links. We need to upgrade our transatlantic links, our side links, all of this stuff basically got a big bump to the next generation. We went from 100 gigs to 400 gigs. We went from 10 gigs to 100 gigs where we needed, and so on and so forth. And OSCARS also needs to be, it implements the transport for some of this traffic. Some of this traffic is done via layer 3, and some of it is done by layer 2 VPNs, where the layer 2 VPN stuff needs to be solid because this is a pretty high-profile experiment. This is the stuff that some researchers are really waiting on. Otherwise, they don't get their papers, they don't get their awards, they don't get their research done in a reasonable amount of time. So we don't really want any downtime for this. And so if you, I should have made a slide to show like how this actually looks in real life, but there's like several primary, secondary, tertiary, quaternary layer 2 VPNs, all designed to be diverse from each other and engineered so that, the whole thing actually keeps working pretty much 24/7. And there's like two really big experiments, one with that basically Fermilab and one with Brookhaven that actually are the big customers. But there's like a huge infrastructure for it. And for the data challenge, we wanted to be ready for this year because we are seeing like a big increase from last year. At the same time, Supercomputing 2023 is where the SENSE project is going to demonstrate some dynamic layer 2 VPNs. And this is a project that is not just involve ESnet. It's a multi-organizational project, multi-network project, multi-facility, multi-levels. It does storage, does compute, it does networking, and OSCARS is actually implementing the networking part of it for ESnet itself. And what they wanted to do this year is to make it a lot more dynamic than before, and which I mean the rate of layer 2 VMs they wanted to spin up at a time went from 1 at a time to 10 at a time. So that was a little more of a challenge and something that compared to the previous state became a lot more important for us to have a infrastructure and the tooling to support that. I'm going to also talk about the IRI. This is another initiative that was announced by DOE. It is, I'm not the right person to talk about it. I'm really low on the totem pole, but this is like a Department of Energy initiative to have to allow all those Department of Energy super facilities and resources to interoperate and be more available to users in a programmatic way. In a way that can be used by automated agents, very much similar to that TIDE talk we had earlier, but I think it's a different funding agency, therefore it's a different project. But the idea is that they want to use these things like these resources in a programmatic manner, in a structured manner, and more to enable our users to do all this beautiful research that they actually do and produce. Actually, I don't know. I see in some of those contexts, I see like people actually using computers to get data, and I'm always amazed at what actually comes out of this. I just take care of the data, moving from here to there, and the science just happens. It's amazing. Now, OSCARS had not been updated for a while. Because it had been a production software, but ESnet had been focusing on a whole different set of automation challenges, very similar to the talk we saw in the other room with Scenics automation. We went through the same journey with NSO, with like a different orchestrator software, but we went through about a couple of years of upgrading our network and automating our templates and all of our stuff, and we had actually let OSCARS like fall back a little bit in this technology. This is a slide about IRI that is somebody better than me on slides made. The general idea is that you want to use an API, here represented by a cartoon robot, to negotiate between different agents, to decide what resources a project needs, how it can negotiate with other automated agents to actually reserve that and provision that at the right times. Now, here I'm sorry, I keep pushing the wrong buttons. But here on the right, you see like the data transport reservations via API. This is where OSCARS and similar agents actually come into this. If we look at this architecture, this is really what we are anticipating utilizing to implement IRI. This Sense software stack, and again, this is not something that I can personally like give you all the information about, but it is a co-scheduling agent, an orchestrator that does networking, that can handle data, that can handle computing, and negotiate all the different components that need to work. And we are actually like, I know that they're demonstrating something in OCF tomorrow, I think. But here we can even see like the Scenic Resource Manager, the Starlight, Fermilab, ESNet's Resource Manager. This is where OSCARS actually lives. But this, it's only one part of a bigger picture that everything needs to work together. Otherwise, we don't get what we need to get for our customers. Now, before, and this is a slide I'm not really proud of, but we had like this whole kind of a monolithic, OSCARS software that had, its front end. It could talk to Sense via a SOAP API, and then it would talk to our devices via this Rancid software. And the Rancid is a good name for that because it didn't smell very good. It's an old way to talk to devices via SSH. It's got some good stuff about it. Primarily, it's quite fast for 2003. And this is actually how ESnet was doing all of its network automation, such as it was until 2022. But we had like our own, Nokia CLI generation templates. We sent all this CLI to Rancid, and sometimes it worked and sometimes it didn't. Most of the time it worked, but that's not good enough when you have a network that actually changes quite often at this point. Like when we have 10 layer 2 VPNs at a time, and a good percent of them actually need to work, and we have a site upgrade, and we have a migration of a port, and all of these changes happening to, on the network at the same time, we needed something better. Now, what we did to do that is that as part of the automation project for ESnet, we basically made NSO services for pretty much the entire configuration of ESnet network devices. We're still in the last stages of that, but almost all of it is now automated. And the layer 2 VPN stuff, well, we sat down, we wrote the YANG, we wrote the Python, the templating, operational states, and all that stuff. And we made the code that works inside NSO. That took us about, I don't know, let's say 3-4 engineer months as a rough, just to see the scale of the effort for that particular service. And this was a huge improvement to just a bunch of CLI, mostly. And I'm not really going to go into how NSO is better than just throwing CLI at a device, but it has improved our experience tremendously. So the main idea that we wanted to do is, okay, there we go. We wanted OSCARS to go take away out of the Rancid, scratch that out, and go through the Cisco NSO REST API, where we keep our service definition, business logic, service configuration blade, and all that stuff. And then that makes the Nokia CLI now, which is what we're working with today. It is not perfect, and if somebody wants to talk to me in detail about this, I'm happy to talk about it, because I did spend a lot of time with it during the pandemic. But I'm happy. It is quite an improvement to before. The next thing we also wanted to do is actually clean up our stack. We had a big monolithic application that was deployed via some Linux software management, RPM stuff. We broke that down into smaller microservices deployed via Docker and Ansible. And right now you can kind of see like that big application, is broken down into like 5 smaller ones. We added a message bus to be able to pass message around components instead of like point to point, where that made sense. And we made a big effort to having a development environment where all of this stuff is actually like instantiated in a safe and controlled way. A lot of the times before now, we didn't really have the capability to even test something without touching a live router in one fashion or another. And I'm not talking so much about OSCARS, but like a lot of our automation stack did not really have a scenario where we could just go and test something out. A lot of the operations we did were on the live network. But we as our certain of our experiences guided us to make basically a reproducible environment that we can spin up even on a single laptop. The infrastructure team helped pushing that automation out to actual production devices and making like the development experience and deployment scenario a lot more smoother than before. This kind of like undersells the complexity of what we have built. There's about 15 or 20 more containers and services that we start up in the automation part of ESnet software. There's also another part of it that is, probably has to do with persona and measurement and presenting stuff to the portal and all that stuff. So there's like it ends up we made a lot of stuff, but at least we are trying to make all of these small enough to be manageable individually and be upgradable and rolled out individually. And we're hoping to get everything into Kubernetes soon. We added some new features to OSCARS. Like we didn't just do like tech debt, which is not very exciting. Some of the stuff that we did, we added the ability to modify stuff in service. This is something that OSCARS actually never had before. It was never designed to begin with as something that you change while something is in service. Most of the time, if we wanted to make a change, something we had to tear it down, make the change, bring it up again. That was just like basically a design oversight that we corrected. And we added a bunch of troubleshooting tools, which I don't know if anybody has ever done like any MPLS or VPLS troubleshooting. It's quite complicated beast because there's a lot of moving parts. There's LSPs, there's like edge ports, there's the service that has them all together, there's forwarding databases. All this stuff is not very easy to debug, and it's kind of arcane, especially in the platform that we're using for our network devices. So we added some operational tools to help our engineers troubleshoot with a click of a button. And we're enriching that as we speak, actually. Today, I'm going to be wrapping up, I think, in a few more slides. We are today at the point where our southbound has been quite a success. NSOifying all the automation stack has made things a little slower because you don't actually get to just talk to the device and send a bunch of stuff. You have to wait in a line, possibly behind another process that needs to do, change the network. You have to, make sure to handle consistency failures. You have to do like things like a lot more structured, but ultimately correct. And the correctness has been a big, big win for us. We do have some bugs, mostly in the front end, and I'm going to speak about that in a minute. And we have had some the ESnet engineers welcome most of our modifications and improvements. We are waiting for more requirements for our community, especially when it pertains to the collaborations such as Sense and RUCIO and on all that effort, because this, the infrastructure is ready, but all the stuff I'm talking about is not actually in production yet. It's still in kind of the demonstration stage. So we're waiting for that to develop a little more. And we are ready for the LHC real data runs. And the instrument has been operational since March 8th. And the data is already flowing over the network. I think, last month we had 100 petabytes or something of data from LHC alone. So and it's an improvement about 100, like it doubled from the month before. Now this summer we do have some plans. We're going to add the SurfNet orchestrator in the middle between OSCARS and NSO. This is mostly to align with other automation tools so that the orchestrator is aware of the OSCARS resources. And we do plan to utilize the Nokia PCE. That is a product that basically does a lot of pathfinding and healing inside the network of LSPs. We have that purchased from and deployed recently, and we're trying to this summer we're going to integrate OSCARS into it. And we are also working on a web UI. It's going to have a dark mode. It's going to be designed by an actual professional at web UIs, as opposed to yours truly that did not do such a good job initially. And finally, we actually plan from some long-term future work. First, we're going to wait for some lessons to be learned, because all these changes for a 20-year project are like, it's going to take a while to make sure to find the successes and failures and figure out what actually is going to be needed. We're going to support IRI and its first implementation. As more like hazy or like aspirational goals, we want to transition to an intent-based approach. Right now, this is quite a prescriptive, I want specifically this and this and this from the network, as opposed to the user saying like what they want and the system deciding what it needs. And we do, one of the things that has been a pattern, I think, in the last 2 years, I think, is that machine learning is a big thing, and handing off your work to the machines can be a big win. And a lot of the stuff that OSCARS does is basically a resource allocation across an entire network. We have 76 routers today. We have 100 layer 2 VPNs, with that probably growing to double that simultaneously in the next few years. We have many backbone links constantly changing status and capacity. So having something that will optimize that, and optimize the future state of it, not just today, is something that I think can be something that we can use machine learning for. That has been all my talk. I'm about out of time. So if there's any questions. All right. Thank you very much.